Dr. Green, in the near future, NASA's Planetary Science Division may be running 3 flagship missions at the same time. The Mars Rover for launch in 2020, the Europa Clipper for launch in 2022, and potentially a Europa lander for launch in the 2024 timeframe. I greatly support this investment and NASA's renewed focus on deep space exploration. At the same time, from an acquisition perspective, this is a great deal of work. What is NASA doing to address the risks of cost and schedule slips associated with this cadence of flagship missions?
Planetary science, I think, has tackled a number of those topics and is doing quite well because we've started to implement a couple very important and new procedures. Typically, strategic missions, NASA's done it in the past based on a science rationale that's almost at any cost. And in planetary science, we have begun the process, in particular with Mars 2020, to have a cost-constrained environment. As was recognized in the planetary decadal, both the Mars cacher and the Europa Clipper were unaffordable, and we took on a process early in this decade to begin to determine what science we can do at that reasonable cost. We are leveraging on Mars 2020 the architecture for Curiosity. We've done a lot of work on the planning of the Europa Clipper, where we're looking at D-scope options. And so some of these processes are incredibly important for us to follow through on.
Okay, thank you very much. And now the next question to Dr. McKinnon. To what extent do the Mars Rover 2020 and Europa Clipper missions align with the decadal survey recommendations?
Well, the original survey considered 2 flagship class missions, Mars Astrobiology Explorer Cacher, and a Europa Jupiter orbiter mission, a mission to orbit Europa itself. And in both cases, the decadal survey concluded, based on a very detailed cost and technical evaluation, that these missions were probably too expensive to be carried out in the decade in question. And so basically they were said, these were our priority missions, but they needed to be de-scoped. They needed to be reduced in cost and perhaps reduced in, and certainly reduced in risk. And in both cases, I think they've done that. As an example, the Europa mission doesn't orbit Europa anymore, but it orbits Jupiter, but repeatedly passes by Europa dozens of times and basically recovers all of the science. And in fact, in my own view, actually does an even better job because it avoids so much of the radiation that's near Jupiter, and it allows, in its long looping orbits around Jupiter that Dr. Pappalardo can tell you about, it can radio back all the data that it collects every time. So, and it does it within a very reasonable cost cap.
Thank you very much. Now, I also would like to ask Dr. Farley and Dr. Pappalardo, the exploration of Mars and Europa are inspiring and truly amazing. As project scientists for Mars Rover 2020 and the Europa Clipper, can you share with us what excites you about these exploration efforts? And what are the greatest scientific discoveries that you're hoping to achieve?
Well, I think the most exciting thing about Mars is that, as I mentioned in my testimony, the surface of Mars carries a rock record from a time period which is completely obliterated on Earth. There is no substantial rock record that is older than about 3.6 billion years on Earth. But those rocks are present on the surface of Mars, and they will tell us a lot both about the way rocky planets evolve and also about things like habitable environments. And for me, the linking this to the life question, I think the really exciting thing is we will potentially be looking at an environment that was capable of having life originate. And that's, of course, one of the great questions. It's a great scientific question that is extremely difficult to treat as a science question because there's no evidence, no substantial evidence to compare it against. By going to Mars, we may actually be able to find environments like that and learn something really profound about the way life works.
Thank you very much. And Dr. Pappalardo.
For Europa, we want to understand, is this really a habitable environment? Europa's ocean, lakes within the ice shell. And we think we know how Europa works, but planetary scientists are always surprised when we actually go there with new instruments to test hypotheses. So we're going to both test hypotheses and explore and expect to be surprised. What I would love to see is some sort of oasis, that is a place where there's liquid water near the surface, there's evidence of heat coming out, there are organics at the surface, somewhere where we'd want to follow up with future exploration.
Fascinating. Thank you. My time is up, so I'd now like to recognize the gentleman from California.